So, we were talking about ratios. Today we're going to talk about what do we use the ratios for. Let's say we had a gear ratio that we talked about. Let's say we have a 5-to-2 gear ratio. That means there's 5 teeth on the driven gear for every 2 teeth on the driving gear. Well, if we have now a motor that has a gear mounted on it already, and that gear has 12 teeth. We need to figure out how many gears need to be on, or how many teeth need to be on the other gear that it's meshing with to maintain that 5-to-2 ratio. The 12 is going to go where? Top or bottom? So of these numbers over here, which one describes the motor, the 2 or the 5?
5.
The 2. That's the motor. That's the driving gear. That's the one attached to the motor. So the 12 goes with that one. They both describe the motor. So we're going to cross multiply. To find this missing number, of course, we could just do, hey, you multiply by 6 to do the fractions. But when we did our percents, we learned how to cross multiply. 5 times 12 is 60. And what do we do with the 2? Divide by 2. 30 teeth is what we need there. Okay, we'll make you a little more comfortable with this next example. So you have a pulley ratio, and we want a 1-to-3 pulley ratio. And let's say the motor is right here, and the pulley on the motor is a 12-inch pulley. Where's the 12 going to go? That's the motor. It goes on bottom, right? So we're still going to cross multiply. 1 times 12. 12 divided by 3 is 4. So we need a 4-inch pulley for the other one. No teeth to count on that one. We could have...
You do realize we're not recording.
There we are.
Oh, sorry.
We do have like the example we did with the roof. Let's say we have a 412 slope. And we want to know how high this is going to be if the span is 40 feet. Well, now remember, what counts for the slope is not the span, it's the run. So we want the 20 feet here, half the span. So 4 over 12, remember, is a rise over a run. Is the 20 a rise or a run? It's a run. So the 20 goes on bottom. So we're going to cross multiply. 4 times 20 is 80. Divided by 12 is 6.67. So 6 2/3 feet. Or 6 feet 8 inches if you want to do the conversion. How would you do that conversion, by the way? I'm going to pull up the calculator here. I'm going to do 4 times 20 divided by 12, which is going to give us 6.6666. Here's what I'm going to do. I'm going to subtract the 6, because we know there's 6 full feet, so we're going to take those full feet off. Times by 12 to convert it back into inches makes it 8 inches. So 6 feet, 8 inches. We've dealt with triangles. We talked about ratios and triangles yesterday. One of the biggest applications of ratios comes in dealing with similar figures. Let's say we have 2 triangles where one is just an enlargement of the other. And let's say this one here is 8, 10, and 4 inches. And in this one, we don't know these 2 dimensions, but this has been enlarged to 10 inches. And I'm going to tell you this angle and this angle are the same, and these 2 angles are the same. What that's telling us is that this side matches up with that side, and this side matches up with that side, the x with the 8 and the y with the 10. If the bigger triangle is just an enlargement of the smaller triangle, that's telling us that those ratios are the same. So what we can do is this. The 10 comes from the 4, or the 4 became 10, or whatever, however you want to say it. Which one do we want to find first, x or y? Let's find the x. Is x going to go on top or bottom? It's going to go on top, because it comes from the same triangle as the 10, so it's going to go with the 10. What's going to go below it then has to be something from the same triangle as the 4, so it's got to be either the 8 or the 10. 8 matches up with the same side as the x, so the 8 goes there. So now we're going to cross multiply and divide. 10 times 8 divided by 4 gives us 20. So x is 20 inches. We can do the same for y. The 10 and the 4 still go together. Where's the y go? Y is still from the same triangle as the 10, so it goes on top. What's going to go below it? 10. So yeah, 10 times 10 is 100, divided by 4, y is 25. What do you think? Not too horrible? Now, some things about these, because of the way they're set up. You know, we've done the cross multiply and divide, but you remember that if you cross multiply, you should get the same answer on both diagonals. 3 times 16 is 48. 4 times 12 is 48. So that's one way you can double check to make that one of these, to make sure that one of these proportions is true, to make sure that both ratios are equal, and they have to be equal to be a proportion. Those two cross products have to be the same. Because of that, there's all sorts of different ways we could arrange this. Let's go back to the roof. No, that's not accurate. Try to make it a little more accurate than that. If this is a 412 slope, and I'm going to put in, let's say this is a run of 18 feet here, a 36-foot span. We set it up as 4 over 12, and then we put the 18 down here, right? And then this was our missing height. But we could have done this. We could have said 4 is the height, is the rise. The height is also the rise. So the 4 and the h could go together. Then the 12 goes with the 4 because it's a 412 slope. The 12 is the run. The 18 is also the run. We could set it up like that. Now this looks like a very different proportion than this, but when we look at it close, you're going to see it's the same thing. We're going to do 4 times 18 and divide by 12. We're going to do 4 times 18 and divide by 12. So it's not like there's just one single way to set up these proportions. There's two relationships. There's a relationship that connects the 4 to the h. Then there's a relationship that connects the 4 to the 12. Those relationships can change directions. You know, we had the 4 and the h horizontal. Here we had the 4 and the h vertical from each other. As long as the relationship is there, it doesn't matter whether it's horizontal or vertical. So because of that, you know, you can switch them around. Now there are fancy names in the book for this. Like this number and this number are called the extremes. You can change the extremes, exchange them. If you move them around, it doesn't change the proportion, because the 4 is still linked to the 8, and the 4 will still be linked to the 12, even if it's down here. Or you could change, these two are what they call the means. You can change those two. If you flip those two around, you still get the same proportion. Again, it's because you're going to cross multiply. But basically what it's saying is, because you're going to multiply the diagonals, you can exchange the two numbers that are diagonal from each other, and it doesn't change the proportion. What if we run into something like this?
I would guess I was in that class already.
You're having a really bad dream.
Yeah.
Well, remember, the diagonal products have to be equal. So if we multiply in this direction, that is 11 times 3x plus 1. That has to equal if we multiply in this direction, which would be 8 times 4x plus 2. Now we just solve the equation for x. Yeah, we multiply the 11, so 33x plus 11 equals, over here multiply the 8, 32x plus 16. And then what? We're going to get rid of one of the x's. We'll get rid of the 32x. So x plus 11 equals 16, and subtract 11, x equals 5. And if you wanted to, you could go back and put that in here. Make sure you get a proportion that's true, but you trust me, right? Sure, why not? In your packet, this will start on page 228, 17 through 40. Same packet as yesterday. There will be a quiz tomorrow, just so you know.
We're not here tomorrow.
Oh, that's right. There'll be a quiz on Monday, sorry, just so you know. The way we decided to do it this semester because of the bridge and the fact that it had to bring David in from outside because we're hitting. I'm gonna pause this because I don't.